Hey everyone, welcome to this explainer. If you've ever tried building an AI application, you already know the absolute headache of getting a language model to reliably talk to the outside world. Well, today, we're diving into the Model Context Protocol, and we're going to look at how it is completely revolutionizing the way AI agents connect to external tools. We are literally looking at a fundamental shift in architecture here, one that turns those clunky, frustrating integrations into seamless plug-and-play ecosystems. Okay, here's a quick look at our roadmap for today. We'll start with number 1, the traditional API bottleneck. Then we'll move into number 2, enter Model Context Protocol. After that, for number 3, we'll actually build your MCP server and wrap up with number 4, empowering the blog writer. All right, section 1, the traditional API bottleneck, when models meet rigid code. Let's kick things off by exploring exactly why the old way of connecting systems is causing so much friction for modern reasoning AI. So what actually happens when a reasoning AI meets a rigid API? Honestly, if you've ever built an app that talks to a model, you've definitely faced this frustrating question yourself. You see, traditional software is deterministic, right? It knows exactly what it needs to do. But language models, they are probabilistic. They need to reason, they need to chain actions together, and they might want to ask follow-up questions. When a fluid reasoning brain meets a super rigid, hard-coded API, you usually end up with just endless prompt engineering, just trying to make them play nice. It essentially comes down to this core conflict. APIs are kind of like locked cabinets. They require a highly specific key. But language models are probabilistic reasoners that just want to look inside an open toolbox and figure out what to use for themselves. With a traditional API, you, the developer, have to read all the documentation, map out the JSON payloads, and literally hard code the exact endpoint logic right into your application. But an LLM doesn't want to memorize a rulebook. It wants rich context so it can organically decide which tool is the right one for the job at any given moment. Moving right along to section 2, enter Model Context Protocol, the ultimate AI translator. This right here is the incredibly clever solution to this exact bottleneck. So, what does it do? Well, MCP acts as a translator by introducing a completely new standardized semantic protocol. Instead of you having to manually teach the model how to use a specific endpoint, the external server connects to the agent and just automatically tells it, "Hello, here are the tools I have available, here's a description of what they do, and here is the exact JSON format you need to use to trigger them." It's entirely self-discovering. It's a real game changer. And there are 4 massive benefits to this approach that really stand out when you're building general-purpose agents. First up is isolation. If your external tool crashes, it's running in its own process, so your main agent stays alive, which is huge. Second is interoperability. Your agent could be written in Python, but your tool might be in Go or Node.js. MCP doesn't care. Third, discoverability handles all those automated schemas for you. And fourth, scalability. You can literally unplug one tool, plug in another, and your agent will instantly read the new context and adapt on the fly. I absolutely love this quote from our source material. MCP is the plug-and-play layer for AI systems. It just perfectly captures the paradigm shift we're talking about here. It turns models into first-class users of software. Think about how HTTP standardized the way websites communicate, giving us the interoperable web we use today. Well, MCP is standardizing how AI environments communicate. You build your connector once, and any compliant model can instantly understand and use it. All right, section 3, building your MCP server, a hands-on exercise. Enough theory, let's dive into the code and actually build a tiny server.py file that exposes a Google Trends tool over MCP. We can break this down into 3 super easy steps to show just how simple it is to bridge the gap between a standard Python script and an intelligent AI agent. First, we write a plain standard Python function that queries Google Trends. Easy enough. Then, we let Google's Agent Development Kit, or ADK, do all the heavy lifting by simply wrapping that function with the @tool decorator. And that step right there automatically generates the schema for MCP, completely removing the need to manually write complex JSON. When you compare the 2 approaches, the magic is just obvious. With a standard Python function, you're stuck manually maintaining a JSON schema alongside your code. But with MCP via ADK, that simple little wrapper instantly converts your function into exactly the JSON schema the MCP client expects. 0 manual hardcoding required. It literally inspects your function's signature and its docstring, pulls out the parameters, their types and descriptions, and instantly builds the metadata the agent needs. Okay, so once that schema is generated, how do they actually talk? Well, ADK routes the tool requests and JSON responses directly over standard input and output streams. Think of it as a direct private wire between the agent's brain and the tool's hands. The agent sends over the name of the tool and the arguments in JSON, and the server runs the local function and passes the JSON result right back. It's lightning fast, simple, and because it runs as a separate process, it's incredibly robust.
And finally, Section 4, Empowering the Blog Writer, Live Data, Better Context. Let's actually see how our new MCP setup breathes life into an AI agent.
We're going to take a blog writer agent, which previously just made up content based on its internal training data, and give it eyes into the real world by adding the new trends_MCP tool. Watch this beautiful sequence unfold. First, you give it a topic. The agent thinks, wait, I need current data for this, so it automatically queries the MCP server, dynamically discovers the trends tool, securely retrieves the live search volumes, and then, and only then, does it actually begin drafting the article. The result? A post that is factually grounded in real-time reality. Absolutely brilliant. As we wrap up this explainer, I want to leave you with a provocative thought to challenge how you design your next architecture. Models are becoming first-class users of software, so are your tools ready to talk to them? Because the era of hard-coded API integrations is officially evolving. If AI agents are going to be autonomous, intelligent operators in our workflows, we have to stop treating them like simple script executors. MCP offers a future where tools organically describe themselves to the AI that needs them. So as you build your next application, ask yourself, are you building locked cabinets or are you building open toolboxes? Thanks for joining me on this explainer, and I'll catch you in the next one.